Hello everyone and welcome to Test Review Day. So, in order to study for Test 2, I would highly recommend looking back at Test 1 and seeing if you got everything right and if you still understand what you were doing then. Because geometry builds on itself quite a bit, so a lot of stuff in Test 2 comes from Test 1 as well. So we'll be going through patterns, we'll be looking at different planes and line segments, how things intersect. So go through and make sure you know everything. Then your homework as well, I would recommend go to the previous last two homeworks, because that's the new stuff that's going to be on the test. So make sure you know that. So that's mostly going to be stuff where we actually add measurements to our line segments and measurements to our angles. And there's also a little bit of algebra where we have to find x given two congruent angles. And then probably the most important is know your definitions. And so for that, you just go to the end of each chapter, look at the rayness section to make sure you know what the definitions are, make sure you can fill in the blanks. Because if you don't know your definitions, you won't know what some of these problems are asking. So I'm just going to walk through a few of the problems you'll probably find on this test. So one of the first ones that we'll be looking at is knowing what a shape is. For example, earlier this year we talked about defining things such as a square. And so here, the shape I am drawing, that is not a square right now. But if I define it as a square, it becomes a square. So a square has four congruent sides and four congruent right angles. So now that is a square. Now let's do the same thing for a triangle. So a triangle is actually a lot simpler than a square because all it requires is to have three line segments meet up at three different vertices. And there we have a triangle. It's very simple. Now, if we move on to some of the next, we need to know how to label things. I noticed a lot of people struggled with this a little bit on the first test. But, for example, if we have line here, and we call it A, B. There are a lot of different ways to label that, and so I'm going to talk through the different things you can label in this line. So first off, we have line segment BA denoted by just the line over top, and you can write that AB as well. For lines and line segments, the order does not matter. Now, the difference between a line and a line segment is a line has arrows above it. Line segment, no arrows. Line, arrows. And then array is where it gets tricky because the order of the arrows matter. Because we have ray B that starts at B and goes off to A, but we also have ray A which starts at A and goes off to B. And you denote that by the endpoint you are starting at, so B, going to A, arrow with one side, so that is ray BA. It is not the same as ray AB. And so, as we look on what we have next, so you'll just want to be able to, so if you look at a three-dimensional shape, you want to be able to identify the planes involved. So for example, if we go back to our three-dimensional rectangle, we have to remember that we have planes on each side of it. And these planes, they don't just stop at the edges. They go on forever. And then we need to know, one of the questions is going to be is, where do the planes intersect? So we have this plane A and this plane V. So plane V and plane A intersect along this line right here. And note, it's a line, not a line segment. So if you want to denote it, if we have our points here and here, we'll call them point. So we have our points at the two corners. We got point E and point F. We'll want to denote that by line, so arrows at the end, E, F. And that's how you deal with this type of problem. And so there will be a bunch of different shapes, kind of like nothing new from what we've experienced so far. It's all going to be based somewhat on what we've done in the homeworks. And so, now here's where we kind of get to new stuff. So we're going to have a line segment. And so on this line segment, this line we're going to make into a number line. So there's going to be a lot of tick marks. And on that number line, there's going to be the line segment. So we got A and B. And so we'll call A at point 2, B at point, let's say, 15. So if we want to find the length of line segment AB, so we have the little m to denote measurement of AB equals 15 minus 2, which ultimately equals 13. Very simple, you just need to know what you are doing. And so, other similar problems, you're going to want to know what congruent means. So congruent means that lines are of equal length. So if we have a triangle once again, and I know this is not quite to scale, but because I make these marks, they are. And so if we have this length of 3, this length of 5, so the problem's going to ask what's the length of this side. And we know these two line segments are congruent, which means this side is also going to be length 5. And so here's one of the more complicated ones where we have to actually use algebra. So if we have line segments here, we got a few line segments here. We'll denote it by point A, B, and C. And these two line segments are congruent with each other. And we got AC, measure of AC, denoted by the equation 5x plus 3. And then we have the measure of line segment BC equals, let's say, 7x plus 7. So the key here is to recognize that these two line segments are congruent with each other, so we can set these two equations equal to each other and get rid of these unknowns because we don't yet know what length of AC is or what BC is. So we're going to start by solving for x. So we got 5x plus 3, which is the length of AC, equals 7x plus 7. So we're going to subtract 3 from both sides, and we get 5x equals 7x plus 4. We're going to subtract 7x from both sides to get it equal. So we got negative 2x equals 4. We divide by negative 2. And we get x equals negative 2. Now this doesn't actually work because I messed up with my signs up above, but this would be how you solve it. And in the test this will work out. So let's say we got negative 7x and negative 5x. This way the math actually works out, and this is a useful problem, which makes this positive 2x at the bottom. So you get x equals positive 2. So, yes, this is just a bad problem. I chose some bad numbers because this isn't going to work out. But you get the idea of what you're supposed to do. You solve for x. Once you get x, you plug it back into these equations, and they'll give you the length for these line segments. Okay, so let's see. What do we have next? So, one of the problems that's going to be on here, you're going to have a supplementary angle. And so, if I have a supplementary angle of 100 degrees, and I want to know what its supplement is, the supplement is the angle that you add to this to get to 180. So essentially you have 100 plus x equals 180 degrees. And we do a little math. You can see fairly easily that x in this case equals 80 degrees. So that is your supplement angle. Now if this would ask for your complement angle, and we have an angle of 180 degrees plus x, and since we're going to do a complement now, that would add up to 90. Since this angle is greater than 90, the complement doesn't exist. And so, for that, you would just write does not exist, and that's it. But if this angle was 10 degrees, our x, 10 plus 80, x would equal 80, so that way we get to our 90-degree angle, and that's our complement. So make sure you know those definitions, as well as definitions such as vertical angle and linear pair, and all the other ones that you'll find at the end of the chapters. So let's see. So here, let's do this one. So let's draw an angle once again. So we have our angles here. So our rays, we'll call this point A. And we got B, C, D. And these angles are named 1 and 2. So we'll want to name this angle in 3 different ways is what the question will ask. So to do that, we can name our angle by 3 letters. So we got angle BAC. The vertex is always in the center. And then normally if D wasn't here, we could also call it just angle A, but we can't, because angle A refers to both angle 1 and angle 2. But since we named these angle 1 and angle 2, we can just go angle 1, and that's another way to phrase it. Then the last one is angle CAB, which is just the letters in the opposite order. So we got Bach, 1, and Cab to name that angle. So as you can see, it's not too hard. You just need to know what you are doing and know what things mean. So for another one, I don't have my protractor with me right now, but there'll be a protractor printed on the test, and you'll just need to be able to read off what the angle measurements of one of those angles are, as well as with congruent angles. Congruent angles are denoted by a little slash mark there. So that angle is congruent with this angle. And so the same number of little marks connecting it make them congruent. So these are no longer congruent unless they have the same number of little arcs in them. and then we'll do the algebra thing once again. We'll see if the numbers work out a little better this time. But we're going to, this time, have our right angle. So it's a right angle, means it adds up to 90 degrees. And then we're going to have a ray coming out of it, which means that these two angles here are complements, since together they form a 90-degree angle. And so we're going to denote this angle by 3x plus 4, and this one by 13x plus, let's say, 6. And so we can't use the congruent thing because we don't know if these are congruent or not, but we can use the idea of the complement, which means that these two angles add up to 90 degrees. So 90 equals 3x plus 4 plus 13x plus 6. Now we reduce this by putting our x's together and our non-x's together, and so we get 16x plus 10. Subtract 10 from both sides, we get 80 equals 16x. 80 divided by 16. Let's see, that would be equal to 5, I believe. So we got 5 equals x. Now let's check this to make sure this works. So if we plug in 5 for x here, we get 3 times 5 equals 15. 15 plus 4 equals 19. Now we have 13 times 5 down here. Our x is 5. 5 times 3 is 15. Carry the 1. We get 65 there. 65 plus 6 is 71. So let's add these two numbers together and see if they equal 90 degrees. So 1 plus 9, that's 10. We carry the 1. So we got 7 plus 1 is 8, plus the 1 we carried is 9, and we get 90 degrees for the whole of that angle. And so I believe that covers just about everything you'll see on the test. So yes, good luck with that. And yeah, if you have any questions, you know what to do.